This broadcast has done extensive reporting on the effects of climate change, and our attention was recently drawn to the Arizona desert.
Everybody wants to get their picture taken with the saguaro cactus.
They are the main attraction.
They are, without a doubt, the main attraction.
John Gurule from Scottsdale Adventure Tours makes his living off the Sonoran Desert, where the saguaro cactus has thrived for centuries. Some of them are well over 100 years old. But now, parts of the Arizona desert are getting too hot for these cactuses.
Just within the last year on this trail that we take, I've noticed 2 of them that have actually been blown over. And to me, that's highly unusual.
What goes through your mind when you see that?
But it's always concerned that, you see that maybe it's something bigger. It doesn't take a rocket scientist to see them and see that it looks like they're melting.
The already arid Southwest has gotten drier over the last 20 years. Starting in 2020, parts of Arizona have seen extended periods of record-breaking heat. 110-degree temperatures lasting for weeks on end are causing the hardy saguaro to drop dead from what amounts to heat stroke. Over the last 5 years, researchers have noticed the death rates of saguaros in the Phoenix area have jumped from 1 to 2% a year to closer to 7%, far faster than a cactus reproduces. And to replace a saguaro like this one can take a century or more. It starts to feel a bit like a graveyard.
It's a little bit like that, yes. When you see
Scientist Kevin Hulteen has been studying the cactuses for 14 years.
We are undoubtedly going to be seeing more and more of these kinds of graveyard conditions as the rest of the desert continues to get warmer and warmer.
Researchers say studying the saguaro's response to heat is challenging in part because the cactuses grow very slowly.
They're not going to disappear completely. But in terms of trying to improve their chances, it really is partly up to us.
So his team at the Desert Botanical Garden is working to identify the most resilient varieties, saguaros best suited to withstand a hotter, drier Arizona. Are we looking at the future saguaro cactus for Phoenix here?
Potentially, yes. Hopefully. That's the idea.
Some of these seedlings will end up in the Tonto National Forest. It will take decades for them to grow and will likely require a symbol of the Old West to find new strength to survive.
Hi there. This is Climate Crossroads San Diego, and my name is Walt. I'm just an average citizen who has questions regarding the response of California's state government and San Diego's local governments to the threat of climate change. Specifically, I perceive a serious gap between the policies intended to protect Californians and the warnings of climate scientists. Each of the 6 episodes that precede this one discussed a different example of this credibility gap. In this video, I'm going to start with a topic that needs to get more attention from our leaders: agriculture. Mother Nature is sending us a message when a plant, the saguaro cactus, that has evolved over thousands of years to thrive in the extreme heat of the Arizona desert, is now threatened by our heating planet. But what about our domestic food crops that have also evolved over the thousands of years since our ancestors began farming our food supply? As you know, agriculture was the starting point for our civilizations, converting from hunter-gatherer lifestyles to the ancient communities of people that led to our modern world. This article from CNN discusses the impact climate change will have on our ability to feed our modern cities and towns. I will quote portions of this article to give you an idea of the existential threat that climate change represents to mankind. Rising global temperatures are set to devastate food crops across the world, with particularly alarming impacts projected for the United States, where production of key crops could plummet 50% by the end of the century, according to a sweeping new analysis. The scientists analyzed 6 crops: maize, soybeans, rice, wheat, cassava, and sorghum, in more than 12,000 regions across 54 countries. Together, these crops provide more than 2/3 of humanity's calories. If the climate warms by 3 degrees, that's basically like everyone on the planet giving up breakfast, he said. The world is currently on track for around 3 degrees Celsius of warming by the end of the century. Wheat, soy, and maize, high-value crops for a lot of the world, will be especially badly affected, the study found. If humans keep burning large amounts of fossil fuel, maize production could fall by 40% in the grain belt of the U.S., Eastern China, Central Asia, Southern Africa, and the Middle East. Wheat production could fall by 40% in the U.S., China, Russia, and Canada, and soybean yields could fall 50% in the U.S. I'm going to close this video with the latest assessment of climate change by Johan Rockstrom. As I mentioned earlier in this video, the actions and policies of our state and local government seem to fall far short of what climate scientists are recommending. I will start by quoting from the YouTube description of Johan Rockstrom's message. The only currency that matters now is speed and scale. At the Green Tech Festival 2025, Johan Rockstrom delivered a powerful keynote calling for urgent, science-based action to safeguard humanity's future. Drawing from the latest Earth system science, Rockstrom warned that we are approaching or already crossing key planetary tipping points, including ice sheet destabilization, ocean warming, and biosphere collapse. With global temperatures accelerating and natural systems losing their buffering capacity, we are leaving the safe operating space that allowed human civilization to thrive for 12,000 years.
We know today that what is at stake is the stability, the resilience, and the habitability on Earth. We're seeing the first signs of a planet losing its buffering capacity to cope with the stress from 150 years of unsustainable exploitation of resources, fossil fuel-based energy systems, and linear supply chains and value chains across essentially all industrial sectors. And the evidence, as you know, is overwhelming. Here you have the exponential pathway in the wrong direction, which shows on the red side the socioeconomic pressures from 1750 until today, GDP growth, population growth, resource exploitation. Up until 1950s, we have a linear, unsustainable use of the planet's resources, a free subsidy to the global economy. And then at the mid-1950s, we have this takeoff point, and we start the hockey sticks of pressure on the planet. The planet responds to the right-hand side with the hockey sticks of carbon dioxide, sulfur oxide, deforestation, biodiversity loss. They show exactly the same pressure. And now, in 2025, we've reached a ceiling. We can today talk of having reached what I call a saturation point, or as the late Professor Will Steffen, who was a co-author of mine with the Planetary Boundary Science, saying we're hitting hardwired biophysical processes that regulates the very functioning of the Earth system. There's no free space left. There's no ample forest or oceans or atmosphere or ice sheets that we can continue exploiting for free, add value, and plug into the economy. We now must operate within the wholly, fully filled up space on planet Earth. But it's actually even more challenging than that. Over just the last few years, we're starting to see signs of cracks in the ability of the Earth system to buffer the changes we're seeing. And the most dramatic graphs, you've probably seen them, are now on the screen here. On the left-hand side, you see atmospheric temperatures, and on the right-hand side, you see sea surface temperatures. The gray lines are observations over the past 20, 30 years. The gray lines are what has driven us scientists to warn that we have a climate crisis. So this is the linear rise of temperatures from fossil fuel burning, land use change, leading to the most unprecedented rapid speed of temperature rise up to 1.2, 1.3 degrees Celsius of global mean surface temperature rise. Then suddenly, in 2023, we have a jump, and in 2024, we have another jump. So what you see here is a sudden acceleration in the rate of warming. That's what is illustrated with the sea surface temperature here. And the red line is 2025. So the drama is that we jump in just 1 year with 0.3 degrees Celsius, which is beyond anything we had expected or predicted. This is an El Niño year, so of course you can always claim that some part of this, correctly, is caused naturally through an El Niño oscillation. But then we have 2025, where we enter a La Niña phase, where you would expect the planet to cool down, relatively cool down, but that's not happening. We're seeing that we continue on this higher rate of warming. And if you show this data in a different way, here you have the hockey sticks of the 5 different sources of temperature measurements in the atmosphere to the left and ocean temperatures to the right. And they all show, and statistically increasing or verifying, that the last decade we have an accelerated rate of warming. And this is a really deep concern, because already the first part of the line is what takes us to the climate crisis. And if we now have a tendency of an even higher rate of warming, that is potentially a first sign of a planet that is no longer able to cope with the pressures. And remember that the planet has, so far, been a remarkably friendly, protective biogeophysical system to our unsustainable pressures. 50% of carbon dioxide is taken up in the ocean and intact nature. 90% of the heat is absorbed in the ocean. 4% of the heat caused by our fossil fuel burning is consumed to melt ice. Are we seeing the first cracks in this ability? That's where we meet here in Berlin. A situation where, if anything, the planet is telling us we have to go faster to be able to avoid dangerous, really dangerous, potentially unmanageable outcomes. Why is this such an important piece of scientific evidence? Well, it's also because we now have unequivocal evidence that we're leaving the corridor of life. Now that is, as you know, coming from data from ice core data. Here you have 400,000 years of the journey of planet Earth. If we start further to the right here, we are at this point at global mean surface temperature of actually 1.3 degrees Celsius. That's the average 10-year moving average. We're heading towards 3.1 degrees Celsius by the end of this century. That's a point we haven't been in for the past 4 million years. To put it simple, I do not hesitate a second to simply say clearly that's a road to disaster. There's absolutely no evidence that we can support the world as we know it in a 3 degrees Celsius warmer planet. Now, we leave a very narrow, stable period, the 12,000 years since we left the last ice age, called the Holocene, a 14 degrees Celsius planet with variability, plus minus 0.5. Can you imagine everything that has happened over the past 12,000 years? A subhumid savanna system in the Sahara, the little ice age in the 17th century, the medieval warm period when the Vikings supposedly crossed the Atlantic and even saw grape grown in the southern parts of Greenland. Yes, but happened within this very narrow range, and we're already outside of it. We were hunters and gatherers here. We've lived through 2 ice ages. Modern humans exist from 250,000 years ago. 2 ice ages. The wider spectrum of the corridor of life is that we've, so far as we know today, never exceeded 2 degrees Celsius over the past 1 million years. Deep ice age is -5. We modern humans through this period. We leave the last ice age as hunters and gatherers, and we enter this incredibly stable Holocene life corridor, and here we invent agriculture. And we start the civilizational journey as we know it today, and we're today 8, soon 9 billion people, and we can today conclude with very high degree of certainty that we depend on the Holocene. Our world depends on the stability of the interglacial equilibrium of the Holocene. Now that is humbling. It's also a bit scary in the sense we're leaving it, but it's also very reassuring because it gives us something to measure against. It gives us a reference point for the planet that we need to preserve. It gives us the landing zone where we need to head in the green tech type innovations. So that's a very important piece of evidence when we develop the planetary boundary framework. Finally, we know today that the planet is a self-regulating biogeophysical system characterized by interactions and feedbacks and has tipping point systems. We have identified 16 tipping point systems regulating the climate system. And here you have them. 6 of them are up in the Arctic. That's the ground zero on planet Earth. You have the Greenland ice sheet, you have the permafrost systems, you have the Barents Sea ice. They're all connected, actually, with the North Atlantic through the AMOC system, the Gulf Stream system that regulates heat exchange all the way down to Antarctica, where you have 3 tipping point systems. But you also have the Amazon rainforest, you have the low-latitude coral reef systems. They are across the entire planet. They regulate our stability wherever you live on planet Earth. I call these the global commons today. And here you have them, the list of 16 mapped tipping element systems. They're actually listed also in the IPCC AR6, Working Group 1, Table 4.10, for anyone who's really interested. But for the first time, we're able to quantify the temperatures where they're likely to cross their thresholds. What does it mean to cross the threshold? It means that a system goes from one stable equilibrium dominated by one set of feedbacks that keeps it in that state, like a stable ice sheet, a white surface reflecting 90% of incoming heat back to space. That's the feedback. That system physically crosses a threshold at the moment where more heat is absorbed than is reflected back to space, and the system starts self-melting. You cannot stop it. The Amazon rainforest can also cross a tipping point when the moisture recycling is interrupted by heat and deforestation. The system starts self-drying, and it turns into an abrupt shift towards a bush savanna. What you see here is the scientific uncertainty ranges. Admittedly, we don't have perfect precision yet. We call these the burning embers. The further to the right you go, the higher the likelihood of crossing a tipping point. The most important message here is look at these dots. This is the median assessment. If you look at the first 5, those are likely to cross their tipping points at 1.5 degrees. The point that we have agreed upon in the Paris Agreement and that we've approached already. We tasted 1.5 already 2024. The Greenland ice sheet, the West Antarctic ice sheet, tropical coral reef systems, abrupt thawing of permafrost, and collapse of the Labrador Sea. Just those 2 ice sheets hold 10 meters sea level rise. I mean, do we need more risk assessment to turn things around, given that we are going to breach 1.5 very soon?
Thank you for watching Climate Crossroads San Diego and being a person who cares about climate change.